Hello, Alexis. Are we back again?
Ciao Stefano, come stai?
Very good, very good. Okay, this episode is really, really buona la prima because we never ever try it. We actually do episode 4 right after episode 3, and
You
we'll
can't
try.
give
We
that away,
yeah,
man. That's our big secret.
we should try to stay within the 15 minutes. Let me start the timer because last time we didn't. And so, okay, I got a counter started. This is officially the starting of the episode 4.
All right.
And okay, this time it's up to me. And what I want to share is one Alex Kelly great dialogue. And this dialogue is about like different way to interact with the SQL-like database in the LLM world, given that we have LLM now. And yeah, before even diving into his lead dialogue, I want to just point out that he is very, very good blog post. And a thing that I see is that he's actually like creating a lot of different posts. And in a lot of these posts, he's adding a video that
Wait. Can I see
explains,
how many posts he has? Can you go back to the main page?
there's a lot of them. There's 2 pages.
Wow. I
Yeah,
see
and
this and it makes me
I
feel
even
bad about my
think
blog. This is
I'm pretty
awesome.
sure that like this one is from last year. Like,
Alex Kelly, I salute you. This is the level of
yeah,
productivity
this is awesome.
in blog posting that I aspire to. Well, carry on. Yeah.
Okay, okay. The
Respect.
last one is
Respect.
actually the one that we were discussing, and
All right.
he is put down very good detailed video, diving into all the detail of his like dialogue. But a thing that I noticed, like looking at this, say, oh, I can spot that this is kind of similar to the shared dialogue. And
Hmm.
looking at the source of the page, I can clearly see that he embedded the iframe with the actual SolveIt shared dialogue. And so the way this like blog post is made is actually wrapping, I think it's a Quarto like
That's Quarto.
infrastructure. Is a Quarto. He injected the YouTube video and he added the straight link to the SolveIt dialogue. And if you look in this way, we always think about SolveIt like this is super hackable system to have like a code and LLM in the same place, and is a great place for reading, as we see in the last lesson with Eric. But it's even like a platform to blog, to create blogs. And really, what you just showed before, I can create a blog with interactive plots all with Solvit using like Altair to create like dynamic visualization, something like that. So it's really, really interesting and powerful to have even another way to look at the same Solvit platform. So, okay, let's jump back to the code. And again, he's diving a lot more on all this topic, but at the end of the day, what he presented is like it shows the 3 different way to search inside SQLite database. And one is like, okay, keyword search is actually using the FTS5 method, that is the full text search inside SQLite. I think it's a BM25 behind the scene.
But
And
pretend that I know much less about machine learning than I'm supposed to know. And you
okay,
say FPS 5. What does that stand for? Just
I
for
think it
everyone else.
stands for full text search, maybe 5.
FTS.
Like
Okay.
BM25, I see best match 25 version.
Right.
I
Oh
I
yeah,
think
no,
I
actually I
remember
remember the
this,
story
but
about this. Why is it called
it's
25? It's because they went through like 24 versions and this was the good one and they
exactly. I
stopped
remember
there.
there was a fun story
It's not
about that.
anything
Yeah,
else.
yeah.
Yeah, I remember it now. Carry on.
Yeah. And then, okay, that's the typical classic full text search we all use to. And the other one is a vector search. That is what we
Hmm.
call usually semantic search. So you search the meaning of something. And the other one, the third interesting one I didn't think usually, is the LLM-generated SQL. So it's the idea that you can make a question in natural language and
Hmm.
have the LLM transforming this question into actual SQL code, running and give you the response about the thing. So let's take a look at how we set up the thing.
Wait,
And
wait,
again,
wait. Before he does, I just want to look at that comparison table. It looks very AI generated with the emojis, but that doesn't mean it's bad.
yeah, the
Um,
emoji can be really AI
so
generated.
so one thing this makes me think about, I just want to share this before we move on, is
Sure.
I was having a conversation with my colleague Nate about RAG,
Yeah.
and we were talking about, everyone. tends to think about RAG as a thing you do with a vector search first to find relevant documents, and then you like dig into those documents to return them. But one question was, well, like, why bother? Like, if you have a good enough, agentic enough LLM that can drive queries, maybe that gets you just as good a result. So maybe that's what this is going to answer. I don't know, but it resonates with
It
me.
depends. Okay, it's a good point, and it's exactly why he really described this very well in this video. Why different kind of searches has different kind of power. Like
Hmm.
one is just faster, another one is maybe cheaper,
Hmm.
another one is resilient, for example, to spelling or to language. So if you're searching with SQL and you're searching for something using like operator, you
Hmm.
really need to know exact piece of the string. So the LLM generated stuff is not resilient to typos. Instead, the spelling, the vector search is actually very good at getting to, even if you make a typo, it get to the point
Right.
because it get to the meaning of the sentence. And even if you make a small mistake, you're not going to lose it.
Right.
But of course, if you're searching for a code, make it like an NSKU for a product,
But
you absolutely want
but
the
that's
like
using
classic search or the
okay.
SQL thing.
But to be clear, that's using an LLM to make a SQL query. And
Yes.
so then the LLM, so that SQL query will end up being sensitive to certain kinds of typos and spelling. So it inherits the same
It
problem as
is
a
a
keyword
simple
search.
SQL query.
Right.
If you search for
But
the
but if
wrong
you were a
string,
real bonehead
you're not going to
about
get it.
if you're a real bonehead about it in the way I might be, or that Nate and I were thinking about, just like have the LLM read lots of text and tell you, right? Because the LLM itself is not going to be sensitive to misspellings. If you ask the LLM, hey, is this document relevant to, this
Yeah,
topic?
but think
It'll
about a brand. Think about, I don't know, Coke. If you
right.
type Coke with 2K, the LLM will understand that you're meaning Coke. Instead, if you search like with the keyword or the LLM, they're gonna like that string somehow, and they're gonna make a
Yeah.
mistake. So
Yeah,
it's the
exactly.
resilience,
Exactly.
or and another thing is like if you're searching for something, explaining yourself, like asking for a meaning or something like that, maybe in a different language, for sure the FTS keyword is not gonna get it. Maybe the LLM gonna understand your different language and do the thing, but
Okay.
maybe using searching for a keyword in Italian instead of in English, and you're not gonna get it.
Certo.
Okay, so
Okay. Yeah, I just want
this
to
was
make
the
clear, I just want to
preamble of the
clarify that
thing.
we're not seeing LLM doing natural language processing. That's a fourth option that doesn't
No,
appear there. We're seeing LLM for SQL generation. Okay. Sorry,
yes,
I'll shut up now because yeah, I'm curious to hear
cool.
what you noticed here.
Okay, cool. So another thing that I want to show here, I want to discuss about is the way that I approach when I deal with something that I found on ShareIt or in general on the web. What I usually do, I take ownership of this. So I take it, the Alex dialog, I put in my instance, and I start to understand and reading first, maybe the first time, and then trying to execute in the code. And like understanding what is written down, maybe trying to get to the point where what he's explaining or what he's doing and installing the library. I actually like have to install Polar, and I didn't know about Polars, and I take a look. Oh, it's an interesting stuff. I want to dive in this in the future. And I understood that Arrow is a library that is needed, and it's needed when you load Polars. Otherwise, not going to get it. So I reordered his original imports to make this and actually continue running. So he's just using a public data set of customer support ticket, classic
Hmm.
first level support ticket. We're just like, I don't know, this is the DF. It's about 28,000 support ticket, for example. It's pretty interesting. There's a lot of things inside there. So you can take a look. You can say, oh, okay, there's a number of tags for each one of those. And then again, he constructed his own data set. And once he created a data frame, he saved the data frame into this database. So now
Hmm.
from scratch, from the original CSV file from Hugging
Right.
Face,
Now he's got a data
created
frame.
a database. And so
Yeah, and
we
now he's got
just
an
wrote
SQLite
this down
database. Okay.
and we write down the same amount of record that I measure in the length of the database. So we're fine. He is ensuring that this file exists. Okay, that's a good
Okay.
thing. And then he just set up his own experiment. And now is to start using the service to try to understand what is inside. Is ensuring that he can query this database. So he's creating a cursor. open the connection with the database, making a
This is
simple
what we
search.
call the SolveIt approach in my company.
Exactly. He's exploring the thing. He's
You do one
exploring the
little
thing.
step at a time, make sure you haven't fallen off the log, just keep walking forward.
Exactly.
Yeah.
Taking a look, what is the data? For example, I understood that the result is returning a tuple. And to understand what's the meaning of each like element in the tuple, you need to take a look at the columns. And so these are the columns and so forth. And so you have like a way to figure out what is what. And after that is actually diving into SQLite Vec library. He was
Hmm.
like deciding between two libraries. At the end of the day, he select this one. And it's kind of interesting because I never used this one in practice. So I installed it. And really, this SQLite Vec library is a pretty like a low level. It just give you the operator to search and to make cosine similarity, just comparing the
Hmm.
vector with the cosine similarity, but it doesn't anything of encoding of anything else. It's up to you
Right.
to create your own embedding. And so he actually used sentence transformer with this simple model that's actually CPU model running on your
Right.
and SolveIt itself. And yeah, it's simply creating, attaching this extension. This thing here is adding new keyword to the syntax of SQLite. No, SQLite have
Okay.
new operator because it like attach and
So
load these
basically
lab
adding
data.
cosine similarity as a thing that can be
Yes,
used
we're
for
gonna we're gonna
querying
see this one.
SQLite.
We're gonna see this
So
one. So
this is a Python library that wraps a SQLite extension that gives you cosine similarity based search.
yes,
Got it.
the
Cool.
CPU operator that lets you do that. And okay, cool. So is what I this I added this one and I made like the solve it thing, trying with the simple thing. What is the encode model doing?
Hmm.
Mainly because I want to see what's the dimensionality. So this encoding created an embedding of like a 384 items. And yeah, just taking a look at the first 10 like
All right.
elements of the thing. It's just like what the shape. The shape is two because I just encoded two sample sentences. Okay. Cool. So again, I because I ran from top to bottom, I actually encountered an error in a function later, and I realized that probably one table has been lost in his original thing. So I asked
Hmm.
SolveIt, "Oh, can you please recreate this to me?"
Oh, that's cool.
And
Yeah.
like the way you explore and you understand someone else's code using SolveIt is kind of incredible because I say, "Oh, I know you were doing these thing later." And I know I need a table to do that. Please give me the code to do that. And so it did it.
Nice.
I added, and everything goes fine. So the good point about this is that to create embedding columns in this library, you need a little bit of code to do that. You need to take the database, you need the encoding model, you need to extract the ticket with the select. So he actually creating the embedding, not only it's creating the semantic, let's call it that, not only of the subject of the ticket, but even the title. So or even the body. So it
Okay.
gets a simple select with the three columns, the row, the subject, and the title and the body, and does the thing, and it concatenates them together into a
Okay.
string. He creates a list attack with that thing, and he embeds all these texts.
So
And one thing,
model.encode is what computes the embedding vector.
exactly.
The
It's a
the string
simple example that we see
concatenation
here.
the string concatenation subject body is what collects the text of which you
Yes,
are
it's
going to
just
compute the embedding
the,
vector. And then
the element
db
that's going to be
execute many
concatenated.
is where you insert the embedding vectors into SQLite, a database,
Exactly. It's
which we've souped up to know how to do cosine similarity with those embedding vectors. Got it.
exactly. We're just preparing the data. We're preparing the thing
Sure.
there and creating the column and filling the values. Okay. And then just to print out some stuff, but now get to the interesting part. So the interesting
Hmm.
part is that you have the search for ticket. Okay, search for tickets is another like convenience function that he did that simply encode even your query with the same model and actually use a selection into the database to do the search of the item inside.
Hmm.
And the thing that I note is that
So is that the
here,
query that uses cosine sim?
yes, this
Okay.
match operator has been created by the package, and this package create a new syntax
Okay.
for
Right.
SQLite
Okay.
is how
So it
you
extends the
extend the
SQLite
syntax
query
of
syntax. Got
SQLite
it.
with that thing. That's probably made in native code and stuff like that. And not only that, but even add a new function vec to JSON because probably I think that I noticed and forgot to mention before, when you insert the thing, he's using like this ticket vect function.
Hmm.
Okay. And this kind of thing is something that has been added by the library itself that extended the syntax of and
Okay.
make more function available to SQLite to deal with vectors. And so, cool. Once you have do these two things, you can encode the new column and you set a column into an embedding and you can search for that same thing. You have everything you
Hmm.
need. And so, yeah, you can simply like do
Nice.
something like network connectivity issue. This simple thing is actually creating, encoding this string into an embedding and using this embedding with the new syntax created by this new library for SQLite that gives you back all the things. And so you actually pretending your SQL has a new way to deal with this thing. Okay.
I
This is a
I think
bad
there was a
insert.
period. Yes, this is cool. So this is a very tidy example of doing embedding based document search with SQLite, which is everyone's favorite
Yeah.
thing because it's like extremely robust, extremely efficient, everywhere, embeddable.
Yeah, okay. I think we already passed the 15 minutes. Let me go very, very fast. So, okay, the last and the third approach he presented here is the one
Hmm.
where we have an LLM creating a SQL query. So you just use Lizette, that is a very general, and
Right.
he create a question, he define a prompt. In the prompt, you tell the system how the table is made in order that the model can
So you give it
create.
the schema so it can make a query. Okay.
You give the schema, you give some hints, you maybe, in this case, I didn't see this kind of thing. Oh yeah, I see it. It's like example of the data inside. If you want a system be able to make a like or make a filter, you need to be provide maybe the values if there are few or an example of those. And cool. So he's just putting the SQL prompt, and now he's actually creating all the LLM connection. Given that this is Lizette, I simply try to change the model from the 4.5, Claude 4.5 that he was using
Should
to the
work.
4.1. 4.1, actually, yeah, I didn't have like at the moment an entropic key, so I just
Oh,
used the one
okay.
that I had. And it works like a charm. That's a good thing about Lizette. It's like Light LLM can wrap this basic function from any kind of language so you can change whatever language model you want. And interesting stuff is even like when you change the language model, the generated query in this case is going to change and you're going to have a slightly different result. And so at the end of the day, look at this. You create a chat using this model. This chat is put in a prompt and displaying the result. And
Right.
he now made a simple function. Okay. This is an example of the SQL result that's created by the system. Let me run to the thing. And so okay. Um, this query, okay, has been created by the question that the prompt that the user made. The prompt was like, I want to find information about this star home ticket and blah, blah, blah. This to concatenating with the prompt, the thing leads to like this kind of final query. What is it? Here's one, this one here. And you
Hmm.
execute the query and you get to some result. So let's you can like pack all of this together, should be in the end,
Hmm.
in a single function. So combining SolveIt way, you make experiment with different pieces, and then you combine all this up in a single function. So single function is it's simple. It's like taking a question, taking the database path that should have already encoded column to
Hmm.
make the embedding search, and a default model, and this is the prompt that was before in around, now is inside a function. And he's doing all the things here at the same time. He's like,
Nice.
think, created a cursor, encoding the like executing the SQL query, getting to the yeah, the SQL query you need what you want to do, running the query, getting the result, and returning the information. It returns like a three-dimensional, the columns, the results, and the what the actual SQL query that has been run, like the one that
Hmm.
the LLM created. And so let's try to check it out. So smart home ticket model is the 4.1 model that I defined before.
Okay.
And actually we're going to find 60 ticket. And if you take a look at the query, you can clearly see that it's try, you say smart home ticket, home automation, or
Right.
smart home is, as we were saying before,
So it's guessing the query
you
space.
don't
Yeah.
have the concept of smart home as a semantic, and you
Right.
search the language model figure out to find a lot of different way where these could have been explained into the different like tags. So pretty verbose query he made, the model made, but it's okay. And yeah, so that's another one. Search a ticket with high priority. In this mobile, the different in this version here, the difference between a semantic search is that priority is a field of our database. And
Mm-hmm.
so the system is understanding that as making like a priority high.
Mm-hmm.
So it's adding a where condition. And this is
Mm.
so interesting. When I was actually finishing to run this notebook, I just realized, why don't we mix together the SQL generation and the semantic thing, enabling the SQL generation using the new semantic defined by the embedding? It's slightly like it's letting the system create SQL query
Mm-hmm.
that has this new match operator, something like that. There's a little bit of
Oh
thing you
yeah,
need
no,
to,
no. Okay, now I see what you mean. Yeah, that would be
and
interesting.
you can blend
The,
together. It's a slightly more complex because you have
yeah,
the embedding space. It's something you create embedding in Python, so you need to have some more handler. But I was just really like a reasoning about this right before the beginning of this meeting, and
that's cool.
so
That's very cool. I think the thing I
yeah,
take
it was
away
very
is
cool.
if you want
Kudos
to
to
do
Alex for making this happen.
yeah, if you want to do a vector, if you want to do embedding search on vectors, you can do it very directly. You don't need to go to some guy's startup to get a special embedded database. People got very touchy about that stuff last year.
Yeah,
Um,
or maybe you will use some known and popular library, but you have an understanding what's happening.
yeah.
You have an
All right.
understanding like why you need to normalize
I
before
think
because
I think we're
yeah.
way past time today, so we
Yeah,
gotta we
yeah.
gotta wrap this up.
This time was the worst. That's up to me.
All
I
right.
know. So
This is good though. I'm glad to see this.
yeah, yeah. It was so
I'm gonna
interesting. I want
note
to
this.
discuss about all this.
All
Cool.
right. Till
Alexis,
next
thanks
time.
so much. Bye. Bye bye.
Bye bye.